Hello and good morning, CTS231 section 875 students for the fall 2016 semester at Anne Arundel Community College. This is the Cisco Networking Academy CCNA 4 course, or the Connecting Networks course. And this morning's video tutorial is going to be on PacketTracer activity 4.2.2.6, where we're going to be taking a look at configuring frame relay, but we're going to be using point-to-point subinterfaces. So in the previous activity, we looked at taking a single physical interface and dedicating that single interface into sort of a multi-point frame relay mode, where we didn't carve it into subinterfaces, but we used it all within one subnet. And so here what we're going to take a look at is configuring point-to-point subinterfaces, where we're going to be creating subinterfaces, in other words, creating logical interfaces underneath a single physical interface, which is different than creating the DLCIs, right? So the previous exercise 4214, we took the single physical interface and we were able to go ahead and create static mappings, right, using the DLCIs that had been provided, and so we had multiple DLCIs, but this is different, right? This is where we're actually going to carve a physical interface, that serial 00 interface, into multiple sub interfaces. And so we've got our addressing table here. So let's go ahead and dive in. So step 1 says configure frame relay encapsulation on router 1. It looks like pretty much very similar to what we just did, except we're going to be doing point-to-point sub interfaces. So the configuration is going to change, and this is one way, and the text I think does a good job on pages 198, 199, where it talks about sort of point-to-point sub interfaces. You typically find those in a hub and spoke type setup, whereas with the multi-point subinterfaces, those are going to be either full mesh or partial mesh. So, you know, the previous exercise we were in a full mesh where everybody was in the same subnet, and we had connectivity to all of the different routers through those static mappings that we had configured. So here we're going to make it a little bit different. So let's get into privilege exec into global config and back into the serial 000 interface. And we're going to say encap frame relay. And we're going to do that same thing here on router 2 as well as on router 3. Let's see, the mouse is not cooperating. There we go. So on router 2, same thing. Interface serial 000 and encap frame relay. And then finally on router 3. And it looks like we've got some IPv6 that's going to be introduced here as well. And remember, that's an important thing about frame relay as an encapsulation type, is that frame relay can encapsulate IPv4, IPv6, IPX, AppleTalk. So just about any layer 3, upper layer layer 3 protocol can be encapsulated with frame relay. And so let's get into interface serial 000, encap frame relay. All right, so we're not even going to test the connectivity because we know that the connectivity is not going to work right now. So as you can see here, all of our interfaces are red in the cloud. So I'm going to issue a no shut on routers 1, 2, and 3. So we'll bring the interfaces up here. All right, there we go. All right, so the first thing it asks us to do is, so we're going to configure frame relay point-to-point subinterfaces. So remember, with the point-to-point subinterfaces, every subinterface is going to be in its own subnet, right? And so this is going to allow us to not have to put in that broadcast keyword, because again, we're doing point-to-point subinterfaces. So this is one way not to have to put the broadcast keyword in and allow us to go ahead and do or run some of the dynamic routing protocols that rely on multicast, RIP, OSPF, EIGRP, and so forth. So here we are on router 1. We're already in serial 000, but remember, we're creating point-to-point sub interfaces. So I'm going to say, whoops, let me exit out here. So we're going to say interface serial 000 dot, right? So I put the dot in here, and we're going to say dot, and they're showing dot 2, but I think they want dot 102. So, well, actually they show dot 2 and dot 3. Looks like they're using the router number for the point-to-point subinterfaces, but I'm going to use the DLCI, and this is something that that I've used. But this is my convention, as I like to use from router 1 to router 2 as that subinterface number. Now you'll notice it says can't create subinterface, and that's because I left off that point-to-point argument, right? Because with the encapsulation set on the serial interface, remember on the physical interface, that's where we set the encapsulation, right? We set it to frame relay on the physical interface. So when I come in to do the subinterface, it already knows that the encapsulation has been set to frame relay, and so it's going to force me to say, are we going to do point-to-point? And let me pull this back here. We'll say 102. Are you going to do a point-to-point subinterface with frame relay, or are you going to do a multi-point subinterface? Because this is very important. So we say point-to-point. And so sometimes learners will see this right away and say, wait a minute, I should be able to create a point-to-point subinterface here, or a multi-point subinterface, but you have to tell frame relay what type of subinterface it's going to be, right? So we know that ours is going to be a point-to-point. Now remember, point-to-point subinterfaces that run between two physical routers are going to be on their own subnet. So we'll say IP address 10.1.1.1, and it looks like we're going to do a /30 here, because this is going to be between router 1 and router 2. Now, we also need to define for the local management interface, I need to be able to, or I need to go ahead and define the frame relay interface DLCI command along with the DLCI, because remember, this is going to kind of allow us to stitch together the LMI derived DLCI to the subinterface, because local management interface, the LMI, doesn't understand subinterface, doesn't know about subinterfaces. So this is where I'm going to say frame relay interface DLCI, and we're going to say 102, right? And typically it's good form to match that subinterface number to the DLCI that you're going to be using. Makes troubleshooting a little easier. And so we'll leave it like that. Now we may lose points because we didn't say .2, and that's fine. We'll go ahead and work through keeping with sort of a better approach. So again, right, we're going to create another subinterface, 000.103 from router 1 to router 3, and I have to tell it, whoops, that it's going to be point-to-point. So now we're in the subinterface configuration mode. So again, a different subnet here. It's not going to be 10.1.1. something. It's going to be 10.1.3. What do they have us using here? 3.2. And let me make sure that's right. All right, between 3.2. So we'll say 255, 255, 255.252. It'll be a /30. And again, we need to stitch the LMI and the DLCI together here. So frame relay interface DLCI is 103, right? All right, so we've got that sorted out. So now, and we're only doing it, is that correct? Let me make sure we've got this right here. Only router 1. Okay, no, it wants it configured on router 2 and router 3 as well. So let's go ahead and pull router 2 up. And again, we're going to do the same thing. So we're going to say, we did a no shut, I think. Yeah, so we did no shut on the serial interface. So now I'm going to say interface serial 0, or actually, let's set the encap here. Encap frame relay. So now when I say interface serial 000 dot, now remember we're on router 2, so 201. So from router 2 to router 1, and what do I have to declare? Well, it's not going to show it here because we're not in the context-sensitive help, but I had to say point-to-point, right, to define that this is a point-to-point subinterface. So I'm going to have to scoot back up here to the table. You can see they use .1 and .3, but we're going to go ahead and we're going to use a better convention, which is to match it to the DLCI, not to the router number, because your router may not have a number, it may be a name. So let's go ahead and say, where are we at here? So we did the interface, we're in the subinterface setup. So now we're going to go ahead and set the IP address for router 2 over to router 1, 10.1.1.2, right? Because remember, this is in that /30 between router 1 and router 2, and then frame relay, interface DLCI, and this is going to be 201 to match that subinterface. So then interface serial 000.203. Can't create it because we have to say point to point, so there we go. Again, whenever you see that can't create subinterface, remember, you're forgetting to define for frame relay, is it a point-to-point subinterface or is it going to be a multi-point subinterface? Okay, so now let's get the IP address set on here. It's going to be 10.1.2.1, and this is also going to be a /30. And then frame relay, the interface DLCI number would be 203. All right, so do show IP interface brief. All right, so everything is up. So everything looks good on router 2. So now let's go ahead and round things out here on router 1. So we already said no shut, so we should be good there. Encap is going to be frame relay. Remember, set the encapsulation on the physical interface. That way now when I say interface serial 000.301, right, what do I have to put? Point to point. There we go. So now I can put in the IP address, which should be 10.1.3.1, 10.1.3.1 /30. Oops, 252. There we go. And then frame relay interface DLCI, right? We need to get the DLCI correct on here. And since it's from router 3 and it matches the sub interface number, we'll go with that. Interface serial 000 dot. And this is going to be 302, going from router 3 to router 2. And it's a point-to-point subinterface. Then we put our IP address in here, which is going to be 10.1.2.2 and a /30. And then frame relay interface DLCI, right? Because remember, we've got to help out the local management interface here, the keep alives. And we've got frame relay interface DLCI, and we're saying that this is going to be 302. All right, so we've got that configured. And let's look over here. So now, add network entries to EIGRP AS1 to reflect the IP addresses above. And I'm wondering, do they have, let's see, do show run. And let's see, I don't think EIGRP is going to be configured. Okay, it is. All right. So, and it looks like it's 0010. Redistribute static. So we're probably going to have to add the entries in. It shows it being done on router 1, but that's probably going to have to be done on all of the routers. All right, so here's what we're going to do. Let's go ahead and say, let's see if we have any EIGRP config right now. We do, and we're advertising out that LAN segment there. But let's go ahead and say router EIGRP 1. And let's add in those two /30s that we just created. So network 10.1.1.0, 0.0.0.3, and then 10.1.3, whoops, right by it there, 10.1.3.0. So now we're advertising, we're actually running EIGRP on those two /30. So configure R2 to use subinterfaces. We did that. And then, okay, good, add the appropriate EIGRP entries for router 2 as well. And again, this is going to establish adjacencies. You'll notice the broadcast keyword, we're not using the broadcast keyword. And the reason that the broadcast keyword is not being used is because these are, again, point-to-point subinterfaces. So you're going from one point to the other. So on these subinterfaces, you don't have access to multiple peers. You've got access across the subinterface to a single peer. Now, this is going to complicate the routing configuration. Again, think about it. If we wanted to do point-to-point subinterfaces and I wanted to try to, create a full mesh, we're going to end up with literally tons of these network statements in our EIGRP config, as well as tons of sub-interfaces that are out there. So this could become rather complex rather quickly, and that's sort of where the multi-point, right, if again, those use cases that the text talked about right around page 197, 198, was that if you're looking to do full mesh, then you want to do multi-point sub-interfaces, and then everybody's in the same subnet. And that's a lot easier than creating multiple point-to-point sub-interfaces, each in their own individual subnet. So on router 2 here, we're going to go ahead and say router EIGRP1, and let's add in the network statement for the 10.1.1. That 201 is going to be 0, and 0.0.0.3, because that's a /30. And take a look at that, right? So then you have the adjacency up there, and as soon as I come back here and say 10.1.2, well, actually, this goes over to router 3, so we're not going to see that yet until we get to router 3. But the adjacency, do show IP EIGRP neighbors, has already come up there between router 1 and router 2. Do show IP route EIGRP. And there, lo and behold, there's that EIGRP learned 192.168.10.0/24, which is this network right here, right, that was advertised by router 1, and I believe it passive that gig interface there, because it doesn't need to run the EIGRP process on that interface. It just simply needs to make sure that it's advertising it out. So router 2 looks good. Let's transition over to router 3. And the completion percentage, pay no attention there. I think we're being punished for not going with the .2 and the .3 and using what I consider a much better, more clear approach, which is matching the subinterface number. And I believe the text actually may have even mentioned that. Matching that subinterface number to the DLCI number that you're going to be using in that frame relay interface DLCI command. Much easier to troubleshoot that. So here on router 3, let's go ahead and say do show run. Let me see what we've got here. All right, so we've got the sub-interfaces. So we're basically going to say router EIGRP1 do show IP interface brief, and we're going to add in the network statements for the 10.1.3.0. That was a /30, and there's our adjacency, right? Pops right up, and between router 2 and router 3, and then let's drop in the 2. There we go. I'm sorry, the first one was to router 1, 301, and the second one was to router 2, 302. So now if I were to say do show IP EIGRP neighbors, what we're going to end up seeing is we've got those 2 adjacencies there. And again, remember, no use of the network command or the broadcast option, right? We don't have to use the broadcast option because these are point-to-point sub interfaces. So that's all configured. Let me double check here. All right, so now let's go ahead and say show frame relay map, and what do we have, right? It's a point-to-point data link connection identifier, so point-to-point DLCI. Our DLCI is 301, and you can see, right, we get the broadcast functionality because it's point-to-point. The status is defined and it is active, so everything is up. It looks good. Let's say show frame relay. Whoops, show frame relay. Not running config there. Show frame relay. If I do a question mark, you can see we can say LMI, right, and we get. And this is where that stitching, this is where it was important for us to say frame relay interface DLCI, and to stitch the LMI to the DLCI is now we get the LMI status for each of the sub interfaces, right? So, and then we can go ahead and say frame relay PVC to take a look at that private or permanent virtual circuit. And it shows us one for each of the sub interfaces. So now the PC and the laptop should be able to ping each other, and this is sort of our true test here. So we'll go to the desktop, the command prompt, whoops, and did not need to see it that large. There we go. So let's bring it down here. and the PC is on the 192.168.10. So can I ping 192.168.10.1, which is probably the default gateway. So I can ping router 1, which is my default gateway, but now can I ping over to the laptop, which is 30.10. So we're probably going to have to ARP here. And let's see if after that, and there we go. We've got full connectivity. And so the completion percentage here, not that important. If I were to say check results, right? It's probably going to ding us for everything to do with the sub interface. Yeah. So you can see the serial, it's marking it wrong because it's looking for this 0.2, the 0.1, the 0.3. And that's okay because, again, we went with a different convention here. If you're looking to get the 100 points, you could certainly use the .2 and the .3. However, sticking with sort of a best practice and something that's going to make excuse me, it's going to make the troubleshooting a little easier, I went ahead and matched our subinterface number to each of the DLCI numbers, something that makes a little bit more sense. All right, well, so far now we've talked about sort of doing a multi-point configuration, right, with a single physical interface. Where everybody was in the same subnet, and now we're coming to point-to-point subinterfaces, where we don't have to use the broadcast argument with setting up the subinterfaces because they are subinterfaces. So by default, this is one way to get around having to use that broadcast keyword, and we can still establish adjacencies. In fact, if I were to come in here, we're running EIGRP, but there's nothing that says that I couldn't say router OSPF1, and let's go ahead and put network 10 dot, and this is router 1, so 10.1.1.0, 0.0.0.0.3, area 0, and then we'll just do it between router 2. I think router 2 was, 10.1.1.2. So we'll pull router 2 up, and if I were to say router OSPF1, network 10.1.1.0, 0.0.0.0.3, area 0. Aha! So take a look at that. So I don't need the broadcast keyword because, again, it's treating it as a point-to-point connection. So, and let me see, do they have the command show IP OSPF interface brief? What about show IP OSPF interface? Yeah, so, and if you take a look here, when we look at the subinterfaces, right, what is the network type? Right, it's a point-to-point network type. So therefore, we're good to go because with the point-to-point network type, and what you read about this in the chapter as you go through the chapter, especially with OSPF, one of the critical concerns is the network type, because the network type is going to dictate whether or not we have a designated router and backup designated router, or the DR/BDR election, right? And so that's the network type really dictates that. In a point-to-point network type, there is no DR/BDR election, so we're good to go, right? We can just simply fire these adjacencies up, and they're going to come up without any issue. All right, well, that wraps up PacketTracer activity 4.2.2.6. Hopefully this has clarified any confusion you may have had with the point-to-point subinterfaces and how to set those up. All right, thanks for watching, and enjoy the rest of your week.